we have a particular non-calc question that says, let's estimate the area between this function, 36 minus x squared, okay, for 0 to 6 there, okay? So we've got this graph here, and we've got a bunch of intervals, and they're all going to be 1 across. So what we're going to say is we're going to try and estimate the area by the over the function rectangles. And so for any rectangle, we can say that it is the width. And the width in this case is always going to be 1. Okay? So we've got this one from here to here. So we can say that our change is always going to be 1. So therefore, we just need to figure out what the value is at every point. So at 0, right? So at this point, 0 times by 1, and then so on, so on. Okay, so let's go ahead and make a bit of a table here. So f of 0, right? F of 0, well, that is equal to 36 minus 0 squared. So that is equal to 36, okay? And then we go, that's like the area of our very first rectangle. Now, when you have like find the f of 1, and that gives us our second rectangle, that's kind of the area at the top there for the second one. And so again, we substitute everything in, and that's going to be that 36 minus 1 squared, which in this case is going to be equal to 35, okay? And then we go to the next one, right? So what is f of 2? Well, again, we'll just substitute that in. What's 36 minus 2 squared? 2 squared is 4, and 36 minus 4 is equal to 32. Again, we keep going. F of 3, right? We go all the way up, basically, all the way up. But we don't go to f of 6. Because if you count the number of rectangles that are here, right? If you count the number of rectangles, we've got 1, 2, 3, 4, 5, and 6. And because we start at 0, we've got 1, 2, 3, 4, 5, and that adds up to 6. So 0, 1, 2, 3, 4, 5, that's 6 occurrences. So I'm just going to fill these in very quickly. If you want to do the mental maths, you can. And if we add all of these up, so we sum all of them up, right, then we get our area, okay? And so our area, if we sum all of these up, is going to be equal to 161, okay? Now it's going to get a little bit tricky here. You do just have to have a scrap piece of paper to be like, what's 36 plus 35, right? And that is equal to 5 plus 6 is 1, carry the 1, we've got 71 there. Then you go to the next one. What is 71 plus 32? And again, do the same sort of thing. 1 plus 2 is 3, and then that 3 and 7 is 0, carry the 100, just keep on going up like that. Cool. So we don't need to times them by 1 because it's kind of obvious there. So that is equal to some of the marks. But now what we've got to say here, right, is it better to use the estimated rectangles from above or below? Let's take a bit of an example here. Let's use the very first bit, which kind of, it looks like this. It's got this axis here, and we go down. And so for the very first one, we start here, right? I'm going to change to a different color. We start here and we overestimate it, and then we go down. Okay, and so in this case here, it's going to be more accurate to use the rectangles from above. Okay, so if we use, this is the rectangles from above, and this is the rectangles from below, we're going to do it in blue. Okay, and if we do it again, we see like the steeper that it is, the more that we're kind of missing out on here. Okay, so if we take a couple of examples, that might make it a bit easier. Let's say we did the overestimation, right? So for 36 minus x squared, and the overestimation, which is the pink one, so I'll change my color to pink, that is f to the 1, or to the 0, sorry, and that's equal to 36, okay? And if I then choose the blue one, my f to the value of 1 here is going to be equal to 35. So we're seeing that we're going to be missing out a little bit, okay? And if we do the next one down, like what's f of uh, 2? So this time we're talking about this area in here. Well, that's equal to 36 minus by 2 squared, which is, yeah, which is that like 32 business. So we can see because of that minus term, right? Because of this minus term here, it's going to be better to overestimate it because then our value that we're inputting is less. So how do we write this with maths? Okay, so what we can say is that if we take the integration from 0 to 6 for 36 minus x squared, and if I quickly do that, then I get pretty horrible numbers to deal with. Oops, getting ahead of myself there. So this is the actual area, and so this here would, this is from 0 to 6. So if we change this number here, let's say like what's the most accurate area from 0 to 1, let's just say, then we can see that our actual value is going to be 36 times by 1 minus 1/3. Okay, so this is just hypothetically from 0 to 1. So that there is equal to like 35.66666 forever. Okay, and if we compare that to our actual results, we can see that the over one, the 36 one, is more accurate. Likewise, if we do it from 0 to 2, let's say, like what's the area from 0 to 2, then we can go 36 plus x, or minus x squared, apologies, and that would be equal to 36 times by 2, and then minus by 2 squared all over 3. And so we can see that our area in this case is going to be that 72 minus by 4 on 3. Okay, and so again, if you add them up, it'll be the over case, the pink one, that's the most accurate. So 1 mark to say using rectangles above is more accurate. Okay, and this is, we can say, because the function is concave down. Okay, and then by doing your tests, you can check it for instance, from 0 to 1 or 0 to 2, and then show that it's more accurate. So we've got plenty more exam questions like this on our website. So you can find it in the link below. And if you still need help, we do offer tutoring online, in person, or group. So reach out and we'll be very, very happy to help. Otherwise, leave a comment, like this video if it really helped you.